All right, so ionic sizes. We are continuing our discussions of trends. Atomic and ionic radius. This is fairly simple. Atomic radius is one of the sets of trends you had to memorize for the first test. Biggest atoms down here in the lower left, smallest atoms down here in the upper right. Now we are adding the slight complication to it that we are talking about ions. So we're adding or removing electrons from / to our neutral atoms. Really simple. If you add electrons, the ion gets bigger. If you remove electrons, the ion gets smaller. So cations, positive ions, are smaller than neutral atoms. Anions, negative ions, are bigger. Okay. So that is one thing they can do. Really simple. Is just ask you to compare an ion to the neutral atom. So that means that the metal atoms, their ions are always going to be smaller because they've lost electrons. The nonmetals over here on the right, their ions are always going to be bigger because they're always going to be adding atoms or adding electrons, excuse me. Now, other thing they can do is throw an isoelectronic series at you. Iso means same. So we talk about, say, isotropic, when something is the same in all directions. Isobars, those are the lines on weather maps. Bar in this case referring to pressure. So the lines on the maps, at the H on one side, L on the other, is talking about places where the atmospheric pressure is all the same. Isoelectronic means the same number of electrons. Okay. So this here is an isoelectronic series. Aluminum 3 plus, magnesium 2 plus, sodium 1 plus, fluoride, oxide, and nitride. These guys all have the same number of electrons, hence an isoelectronic series. Which of these atoms is the biggest? Which of these atoms is the smallest? Okay. I'll tell you right up, neon's not going to be the right answer for either of those. No, cross off neon. Instead, aluminum will be one, nitrogen will be the other. Which one is the big one? Which one is the small one? Well, just remember, anions get big and fluffy, cations get small. Another way of looking at it is that although these guys have the same number of electrons, they have different numbers of protons. Okay, you hop back on over to the periodic table. Aluminum here has 13 protons, and nitrogen only has 7. They each have 10 electrons, but differing numbers of protons. Aluminum's 13 protons are going to be really good at pulling on those 10 electrons. Nitrogen's 7 protons are not going to be nearly as good. So nitrogen is going to be the biggest of those ions. Aluminum is going to be the smallest because aluminum started with 13 electrons, and every time you remove an electron, it's like throwing water on a cat. Okay, cats are surprisingly small when they're wet. Meanwhile, nitrogen, it's like scaring a cat. Fluff, fluff, floof. Right, maximum floof. Okay, so when you're looking at an isoelectronic series, the positive ion is going to be the smallest. The negative ion is going to be the biggest. Okay, the most negative and the most positive, I should say. So, as with atoms, so it is with ions. You're going to be expected to compare atoms and their ions to determine which is bigger. So chlorine versus chloride. Chlorine is the neutral atom, chloride is the anion. Well, you add an electron, it's gotten fluffier. Magnesium versus magnesium ion. Magnesium ion is lost 2 electrons, it's gotten smaller. Okay, so chloride is bigger than chlorine, magnesium is bigger than magnesium 2 plus. They can also ask you to compare different ions to determine which one is bigger. So which is bigger, sodium 1 plus versus potassium 1 plus? Well, sodium 1 plus is this guy here, minus an electron, and then potassium 1 plus is this guy right here, minus an electron. Well, regardless of the fact that they formed their ions, sodium is 1 energy level lower than potassium. It's just going to be smaller. Okay, for the exact same reason that neutral sodium would be smaller than neutral potassium. But what about potassium versus calcium? Potassium 1 plus versus calcium 2 plus. Well, here's potassium, and then here's calcium. That's just a small chunk, a small piece of an isoelectronic series. So potassium loses 1 electron, it'll have a total of 18. Calcium loses 2 electrons, it'll have a total of 18. So calcium's 20 protons are going to be pulling on those 18 electrons harder than potassium's 19 protons can pull on those 18 electrons. So calcium 2 plus will be smaller than potassium 1 plus. So that's a lot like looking at effective nuclear charge, because the calcium atom is also smaller than the potassium atom. So there's not a heck of a lot going on here. As with atoms, as with the neutral atoms, you're going to have to explain the sizes of ions in terms of effective nuclear charge, shielding, things like that. No really new stuff going on. Yeah. Same basic principles, just with the added complication that they're ions, and we throw the big fancy word isoelectronic at you. All right, and that does it with this particular thing. I'll be back in a few minutes to finish up